Now we extend the idea of the operation on words to languages. Let's consider first language L1, and let's say L1 is the language of all words a to the power of n, where n is greater or equal to 0, so it's a sequence of a's. And consider second language, let's say L2, and L2 is the set of b to the power of n greater or equal to 0. So it's a sequence of b's. What we can now do is we can construct the concatenation of both languages. So we can have a look what happens if we try to concatenate both languages. How could we define it? And actually it's quite easy. You just take one word from the first language, one word from the second language, and you combine them. And the set of words that can be combined like that, that's the concatenation of the two languages. So in this example, the concatenation of L1 and L2 is the set of words W1, W2, such that W1 is in L1 and W2 is in L2, which is actually the set of strings a to the power of n, b to the power of m, such that n is greater or equal to 0 and m is greater or equal to 0. Note here that a is to the power of n, whereas b is to the power of m, because we do not require that the number of a's is actually equal to the number of b's. We can take, for example, the word aa from L1 and combine it with the word b from the second language L2. So we would arrive with the word aab. So the number of a's is not equal to the number of b's. So that's concatenation of languages. Concatenation of languages is just the set of all words such that the first word is in the first language and the second in the second language. Definition. Let L1, L2 be languages. Then the concatenation L1 and of L1, L2 is the set of all words W1, W2 such that W1 is in L1 and W2 is in L2. So that's concatenation. For words, we also defined the power. And we can do the same with languages. We can define the power of a language. And so we take a language, let L1 be a language. Then L to the power of P is the set of all words W1 to W P. So you take P words. Each of these words is taken from the language L and you just concatenate them. So L to the power of P is the concatenation of W1 to WP such that WI is in L for I in 1 to P. Once we've defined this, there's a special operation that will be very useful, and that's the so-called Kleene star operation. And actually, with this star operation, it's possible to get all the possible combinations you can get from combining words from a language. That's the Kleene star. Definition, Kleene star. We take a language. Oh, this should be L1. Let L1 be a language. then L star is the union of L to the power of I. So you take an arbitrary number of letters and you just combine them. And the set of all these letters you can create by this definition, it's called the star closure, the Kleene star of the language. And there's a special definition. What does it mean if we take a language or word to the power of 0? And we define it to be the language the language that just contains the empty word. We further define L to the power of 0 is the set that just contains the empty word. And for a word, W to the power of 0 to be epsilon, the empty word as well. So if we take the language L1, for example, and compute the Kleene star for this language, we'll see that actually nothing changes. Because in L1 we have an arbitrary number of A's just concatenated. And if we do this iteratively, nothing changes. So it would be boring to look at this language. Same for B. So let's consider another language. For example, the language L3 and the language L3. Take a very simple language, just having the letters A and B. In this case, if we take the Kleene closure, if we compute L3 star, then we have the set of all words that we can actually build by combining A's and B's. So it's the set of all words from letters A and B.